Why do you feel burned out, even when you are not doing as much as before? You feel tired, unmotivated, and emotionally drained, and even rest does not seem to fix it. And this is not just exhaustion, it is a system-level response in your brain. Burnout is not a single problem. It is the result of prolonged stress interacting with your brain's motivation system, emotional regulation system, and energy regulation system. Let's start with the stress system. Chronic stress keeps the HPA axis activated, which means cortisol remains elevated over long periods. And while cortisol is adaptive in short bursts, sustained exposure disrupts neural and metabolic balance. Now let's go deeper into cortisol. Long-term cortisol elevation impairs hippocampal function, affects memory consolidation, and disrupts circadian rhythms, leading to poor sleep quality and reduced recovery. At the same time, cortisol alters dopamine signaling. Dopamine is responsible for motivation and reward prediction, and under chronic stress, dopamine release and receptor sensitivity decrease, reducing the perceived value of effort. This is why things that once felt meaningful now feel empty. Now consider the reward system. Your brain continuously evaluates effort versus reward, and when effort remains high, but reward becomes unpredictable or delayed, your brain downregulates motivation to conserve energy. This is not laziness. It is efficiency. Now let's look at the prefrontal cortex. This region is responsible for executive function, including planning, attention, and self-control. But under prolonged stress, its activity decreases, reducing your ability to initiate and sustain effort. At the same time, the amygdala becomes more reactive, increasing emotional sensitivity, threat perception, and negative bias. This creates a functional imbalance. Less control, more emotional load. Now let's bring in the autonomic nervous system. Chronic stress shifts your system towards sympathetic dominance, meaning your body stays in activation mode while parasympathetic recovery becomes insufficient. Over time, this reduces your baseline energy. Now combine these effects. Reduced dopamine, weakened prefrontal cortex, increased amygdala activity, chronic sympathetic activation. This creates the biological state of burnout. Now let's connect this to psychology. Burnout is defined by three core components: emotional exhaustion, depersonalization, and reduced sense of accomplishment. Emotional exhaustion is the depletion of emotional resources. Depersonalization is a sense of detachment or numbness. Reduced accomplishment is the feeling that effort no longer produces meaningful results. Now add learned helplessness. When repeated effort does not lead to reward or control, your brain updates its prediction model and reduces future effort because it assumes that action does not change outcomes. This is a protective mechanism. Now think about behavior. You try to start something, but it feels heavy. You try to rest, but it does not restore you. You feel stuck between effort and fatigue. This is burnout. Now here is the key insight. Burnout is not solved by pushing harder because the systems that support effort are already depleted. So recovery must target the system. First, reduce total load. Not only physical work, but cognitive and emotional load, because your brain processes all of them similarly. Second, restore dopamine. Small, achievable actions with immediate feedback help rebuild reward signaling and motivation. Third, rebuild recovery. Sleep alone is not enough. Your brain needs psychological detachment from stress, meaning time where you are not processing demands. Fourth, regain control. Small decisions with clear outcomes help reverse learned helplessness by updating your brain's prediction model. Fifth, regulate physiology. Breathing, movement, and low-intensity activity restore autonomic balance and reduce sympathetic dominance. And finally, allow time. Because burnout develops over time and recovery follows the same principle. Your brain is not broken. It is adapting. But adaptation can be reversed because your brain is plastic and systems can be rebuilt. If you found this helpful, subscribe to Nexplain.